Okay, we're going to look at finding the composition of two functions. This is where you are putting one function into another. So the notation looks like this, and the way we read this is we say f of g of x. Okay, another way of expressing this would be to use this notation where you see this little open circle in between the two functions in parentheses, and then you have your x on the end. So what you have to keep in mind here is when we're doing the composition, when you're putting one function into another, you are always working backwards from right to left. Okay, so if we're looking to find f of g of x, we would take g of x's equation, put it into f's equation wherever we see an x. Let's look at an example. Okay, in this example we have an equation for f of x and for g of x. We're looking to find f of g of x. So again, understand this is the same as if it were expressed like this. Okay, so what we're looking to do here is find f of g of x. That means I have to take the g of x expression, which in this case is x plus 1, and I need to put it into f where I see an x. So that means this is going to go in right there where I see an x. So if we make that substitution, we would have 4 minus the quantity x plus 1 squared. And let's suppose that we need to simplify this. Well, when we do our FOIL on this piece right here, we end up with x squared plus 2x plus 1, and all of that is in parentheses with a negative in front, and from there we would need to distribute our negative to each term, and we can combine our 4 and our negative 1 into 3. And if we were to express this in standard form, where we start with our highest power and go down from there, this is what it would look like in simplest form. Okay, and finally, suppose we want to find f of g of 2, which again is a reminder, they could have said to find this written in that form. Okay, it would mean the same thing. So in this particular case, again, we got to work from right to left, or inside out. We need to find g of 2 first. So if I'm going to find g of 2, then that means I'm going back up here to my g of x equation, and I'm going to drop in a 2. That's going to give me 3. And then from there, I would need to take that 3 and put it into my f equation. So f of 3, well, my f of x is 4 minus x squared. So if I were to drop in a 3, we would have 4 minus 9, which would give us a final answer of negative 5. Now, that's one way of finding f of g of 2. The other way, well, keep in mind in this previous part here, we found f of g of x. That fits the mold of what you see here. The only difference is instead of an x, we have a 2. So if you were to find f of g of 2 using that expression, using this answer, let's see what would happen. So we have our negative, and then we would drop a 2 in where we see an x. So if we do this, we're going to have a negative 4 minus a 4 plus 3. When we clean this up, notice we're going to get negative 5. So it really doesn't matter which technique you use. However, if you just spent the time up here to find your expression for f of g of x, you might as well use it to save yourself a little bit of time.